In this video, we shall study how to calculate the oxidation number of central metal atom in a coordination compounds. Oxidation number is defined as the actual or apparent charge. It is the actual charge possessed by an atom of an element in the compound. Oxidation number is the actual charge of the atom. So here we can see how to calculate the oxidation number of the central metal atom. In the coordination compounds, we already know that metal is surrounded by the ligands. Ligands consist of pair of electrons which are donated towards the metal atom, donated to the metal atom through coordinate bonds. So now here we can study that how to calculate the oxidation number of the central metal atoms. To calculate the oxidation number of the central metal atoms. Now here we can solve the oxidation number for the coordination compounds having the positive charge. Coordination compounds having the positive charge. Let's take this complex as an example. See, it is having a positive charge. Here it is the central metal atom and these are the ligands. Now how to calculate the oxidation number of the central metal atom? I will just say here. We don't know the oxidation number of the platinum here. So we should consider it as X plus how many number of NH3 are there? 6. And NH3 is having the oxidation number that is 0 because it is a neutral atom is equals to the charge on the complex is plus 4. So it becomes X is equals to plus 4. So the central metal atom is having the charge that is plus 4. That is Pt is having the charge plus 4. First consider the example of Pt NH3 6. The complex having the charge 4 plus and we don't know central metal atom's oxidation number. So consider it as X plus how many number of NH3 are there? 6. And the charge of NH, oxidation number of NH3 is 0 is equals to plus 4. X is equals to plus 4. It is a oxidation number of Pt. Now coordination compounds having the negative charge. FeCN6 4 minus. The charge on the complex is 4 minus. Now we can calculate the oxidation number of the central metal atom. We don't know the oxidation number of the central metal atom. Let's consider it as X plus Cn. How many number of Cn are there? 6. So oxidation number of Cn is minus 1 is equals to the charge on the complex is minus 4. That is X minus 6 plus into minus 6 is equals to minus 4. X is equals to minus 4 plus 6. S is equals to 2. That is the oxidation number of the Fe is 2 here. Now FeCN6 complex is having the charge 4 minus. We don't know Fe, so let consider it as X plus how many number of Cn are there? 6. The oxidation number of Cn is minus 1 is equals to charge on the complex is minus 4 and we can calculate like this. X is equals to 2. We will get X is equals to 2. It is the oxidation number of the Fe. Oxidation number of Fe here is 2, that is plus 2. Now in the neutral compounds we can calculate the oxidation number of the central metal atom. NiCO4. Here it is a neutral compound, it does not have any charge. We don't know Ni here, Ni's charge here. We can consider it as X plus 4 into 0 is equals to 0. Because it does not have any charge, it is 0. 4 into 0, here CO oxidation number is 0 because oxygen is having minus 2 and carbon is having plus 2. It becomes 0. Plus 2 and minus 2 becomes 0. X plus 4 into 0 is equals to 0. X becomes 0. The oxidation number here becomes 0. Ni's oxidation number is 0. That is NiCO4. Here Ni we don't know it. We can consider it as X plus 4 into 0 is equals to 0 because it does not have any charge. So put it as 0. It becomes X becomes 0. The oxidation number of the Ni here is 0. It is for neutral compounds. Now for the coordination compounds having more than one ligand. Coordination compounds having more than one ligand. COCl3, NH3 thrice. See, here the central metal atom is having more than one ligand. Cl3 is one ligand and NH3 thrice is another ligand. So here we can calculate the oxidation number for the central metal atom. We don't know this. We will consider it as X. That is the central metal atom is X here plus 3 into the oxidation number of Cl is minus 1 plus 3. NH3 is having oxidation number 0 and it becomes 0. It does not have any charge. So here we can consider 0 and it is for more than one ligand. Here CO is having two ligands. X minus 3 plus 0 is equals to 0. X becomes plus 3 here. The oxidation number of CO is equals to plus 3 here. For the coordination compounds having negative counter ion, we can calculate the oxidation number of the central metal atom. Here Cl is a counter ion, that is it is present outside the square bracket. CrCl2 H2O4, Cl is an example. We can calculate the oxidation number of the central metal atom here. See, here counter ion is having the charge, that is minus 1. Cl is having the charge minus 1. So the complex will have the exactly opposite charge of the counter ion. Here Cl is having the minus 1 charge, so the complex will have the charge plus 1. Did you get my point? Here the Cl, the counter ion, that is the ion present outside the square bracket, is having minus 1 charge, so the complex will have plus 1 charge here. So we can calculate here. We don't know Cr. Let's consider it as X plus 2, that is Cl2, 2 into Cl oxidation number is minus 1 plus 4 H2Os and the oxidation number of H2O is 0. It is a neutral, so that's why it is 0, is equals to plus 1. That is the charge on the complex ion is plus 1. It is exactly opposite of the counter ion. Here we can calculate minus 2 plus 0 is equals to plus 1. It becomes X plus into minus 0. It becomes 3 here. Here the oxidation number of the Cr is equals to plus 3 in this. Consider another example for this, that is coordination compounds having negative counter ions, that is NH3 4 SO4. Here SO4 will have -2, and here we don't know the oxidation number of Cu. Let's keep it as X plus 4 into 0, that is NH3 is 0, oxidation number of NH3 is 0, is equals to plus 2. Why? Because here the counter ion is having the charge -2, so it becomes exactly opposite of the SO4. So it is plus 2. If it is having -2, the charge on the complex ion will become plus 2. X is equals to plus 2. Here the oxidation number of Cu is plus 2, that is Cu is having the oxidation number plus 2. Now here we can consider another example, CrEn3Cl3. Here En means ethylene diamine. Here Cl is negative counter ion, Cl1. The number of Cl's here is 3, so -1 into 3, it becomes -3. So the charge of the complex ion here becomes plus 3, exactly opposite of the counter ion. Here Cl is having the -1. -1 into how many number of Cl's are there? 3. So Cl becomes -3. The charge on the complex ion becomes exactly opposite of the counter ion, that is plus 3. Here Cr we don't know it, so let's consider it as X plus 3 into 0, that is ethylene diamine is neutral, so 0 is equals to plus 3, that is X is equals to plus 3. That is here is having the oxidation number plus 3. Here is having the oxidation number plus 3. Now for the coordination compounds having the positive counter ion, K3FeCN6. So here the counter ion is K, that is it is having the oxidation number 1. So how many K are there? It is 3. 1 into 3 is equals to plus 3. So the charge on the complex becomes -3, exactly opposite of the counter ion. So here we don't know Fe. Let's consider it as X plus 6 into Cn is -1 is equals to -3, exactly opposite of the counter ion. The charge of the complex ion is exactly opposite of the counter ion. So X -6 is equals to -3. Here X becomes plus 3. That's it. Here for a positive counter ion, here the counter ion is K. It is positive, that is it is having 1 oxidation number, 1 into 3, that is 3 K's are there. So 1 into 3 is equals to plus 3. FeCN6 -3. Here we should calculate the oxidation number of the central metal atom, that is Fe. We don't know it, so let's consider it as X plus 6. How many number of Cn's are there? 6. Cn is -1 is equals to -3, exactly opposite of the counter ion. It is having plus 3 charge, so it is exactly opposite of the counter ion, so it is -3. The complex ion charge is -3. X minus 6 is equals to -3. X is equals to plus 3. So here the oxidation number of the Fe becomes plus 3. We shall consider another example for positive counter ion, that is K3FeC2O4 thrice. Here the counter ion is having, K is having 1, and 1 into 3 is equals to plus 3. How many number of K are there? 3. So 1 into 3 is equals to plus 3. Here the complex is having the charge -3, that is exactly opposite of the counter ion. Here we don't know Fe. We shall consider it as X plus how many number of C2O4 are there? that is 3 into C2O4, the oxidation number of C2O4. See here it is C2O4, 1, 2, carbons are 2 and oxygens are 4. So here is minus 1 and here is minus 1. It totally becomes minus 2. It is minus 2 is equals to minus 3. That is charge on the complex ion. X plus into minus minus, 3 2s are 6, minus 3. X is equals to minus 3 plus 6. X is equals to plus 3. It is the oxidation number of the Fe. Here is plus 3. First, here the K is having 1 oxidation number. 1 into 3 is plus 3. The counter ion is having plus 3. Means the complex should have minus 3. Exactly opposite of the counter ion. So here Fe we don't know the oxidation number. Let's put it as X plus 3. How many number of C2O4? 3. And minus 2 means here COO, COO. COO consists of 1, minus 1 and minus 1. It totally becomes minus 2. That's why it is 3 into minus 2 is equals to minus 3. That is the charge on the complex ion is equals to charge on the complex ion, that is minus 3. X minus 6 is equals to minus 3. X is equals to minus 3 plus 6. X is equals to plus 3. That is the oxidation number of the Fe is plus 3 here. That's it. These are the tricks to calculate the oxidation number of the central metal atom in the coordination compounds. Please do subscribe our channel. Thank you.